Every exam, you will come across a certain question that will ask you to do integration by parts. Okay, it might be a direct question or it might be under an area under curve kind of question. Okay, so the important thing is you must, number one, write down the integration by parts formula. That will be integral of uv prime is equals to uv minus the integral of u prime v. If at this point of time you still don't know how to use integration by parts, please refer to my video in the previous chapter. I gave an extensive explanation of how by parts is being derived, how to remember the formula, 5 types of by parts question that you have to know, how to identify LIATE, okay, and use it to identify your U. So I'm not going to explain how to do that. If you want to know how to do that, please go to the previous chapter and take a look at it, okay. If you look at this question by LIATE, okay, this is ln, so this, and I can only differentiate ln, so ln x is going to be my u, this is going to be my v prime, okay. So I like to use this table, which I derived it myself. My ln x is u, differentiate ln x, I will get 1 over x, okay. X to the power of negative 3 is my v prime, integrate x to the power of negative 3 will become x to the power of negative 2 over negative 2, because when I integrate, I increase the power over the new power. So all I'm going to do here is to present it nicely with definite integrals. Okay, so this is equals to, put a square bracket, uv, so this is my u, this is my v, put it nice at the same time, 1 over x squared ln x with my definite integrals 2, 1, minus the integral of u prime v. So the good thing about doing it this way is I can see my u prime v nicely over here. Okay, 1 over x, that will be x power negative 1 multiplied by x power negative 2 over negative 2 dx. Okay, definite integrals to put in there, negative 1 over x squared ln x, you can just keep it there first, minus, okay, I will change it to plus half, I will bring out the constant, x to the power negative 3 over here. Okay, I'm going to integrate it again, 1 over x squared ln x with 2, 1 plus half, definite integral, 2, 1, x to the power, I'm going to integrate x to the power negative 3 right now. Okay, that will be x power negative 2 over negative 2 with 2, 1 over here. So now I can start to put it in. I'm going to have negative 1 over 4. You cannot bring out 1 over x squared because it is a variable, so be careful. Ln 2 minus, I know that I'm going to put 1 into my x, which will give me ln 1, which is 0, so I can no need to write it, okay? Plus half, but if you're going to be careless, then it's better, you write it, then after that eliminate it yourself, okay? This, at the same time, I'm going to make this nice, 1 over 4, 1 over x squared with a 2 and a 1. So I'm going to write everything nicely now, negative 1 over 4 ln 2 minus 1 over 4. Put in, that will be 1 over 4 minus 1, and I'll get my final answer, negative 1 over 4 ln 2 plus, that will be 3 over 4, 3 over 16. Okay, so this is just one easy case of doing integration by parts. So this is what happens is when you have your uv, your definite integrals are there already, then you have to put in the upper limit minus the lower limit. Okay, for something that is more tricky and it involves Trigo, okay, and I purposely chose this question because students generally don't like to integrate cosine square, okay, or use the wrong thing to integrate cosine square. So over here, I did say that, oh, when you integrate cosine square, you are just going to change it to this form. When you are going to integrate sine square, you are just going to change it to this form. Now, where does these two come from? It comes from, of course, my best friend cosine double angle formula, 2 cos square A minus 1. If I make cos square A the subject, this will be cos 2A plus 1 over 2, and that's how I get this. Same thing, it is also equals to 1 minus 2 sine square A. Okay, so don't need to memorize, know how to derive, because there's a gazillion other things you need to memorize anyways. Okay, so we look at this question, may look very complicated at the start, okay, but let's just apply our L-I-A-T-E, this is algebraic as well, and then this is Trigo. Algebraic comes before Trigo, so my x is my u, and this is my v prime. But later on, when you need to integrate cosine square, you're going to get into a little bit of a trouble. So differentiate, I get 1 cosine square x. So what is the integral of cosine square x is going to be troublesome over here. So integrate cosine square x dx is the same as integrate cosine 2x plus 1 dx, which I'm going to get a half on the outside. Integrate cosine, that will be sine 2x over 2 because of the angle plus x. Okay, don't have to write the plus c. So in this case, I'm just going to write, oh, this is 1/4 sine 2x plus half x as my numerator. Sorry, as my v. Okay. So for this, let's just apply our by parts formula. Okay, uv. So with this table, it is very nice. I can see my uv very clearly, which is here. U prime v is here. Okay, so everything is nice. Put it in, x times 1/4. This is going to be a bit troublesome. Sine 2x plus half x. Okay, with my definite integral pi and 0 over here, minus the integral of u prime v, 1/4 sine 2x plus half x. And because I multiply by 1, okay, I don't have to care that pi and 0. So as I put in my value of pi for the first expression that is already integrated, okay, that will be pi, or I actually should make it nicer first. 1/4 x sine 2x plus half x squared with a pi and a 0 over here, minus, I can split all of them up, no problem, or I can just keep them inside. 1/4 integrate sine is negative cosine 2x over 2, okay, plus half x squared over 2 with a definite integral pi and 0. And now all I need to do is to put in my definite integral, okay, and I realize that there will be a lot of zeros, okay, plus half pi squared. This will be my first one, minus, if I put in 0, that will be 0, so I don't need to care. Put in here 1 over, okay, so this you have to be very careful, 1/8 cosine 2 pi plus, oh, what's happening over here? This is x squared over 2. Okay, 1/4 pi squared minus, okay, be very careful, minus, so if I put in 0, when I have a cosine 0, it's going to make a difference, 1/8 with a negative cosine, okay, not the most neat, but let's clean it up. Negative 1/8 cosine 0, yeah, okay, yes, cosine 2 pi is actually equals to 0 if you visualize the graph well, okay, then you're just going to left with half pi square, minus cosine 2 pi is going to be equals to 1, so it's going to be quite tricky over here, negative 1/8 times 1 plus 1/4 pi square plus cosine 0 is 1/8. That will actually give me 0 again. Yeah, over there. My final answer is like pi square over 4. Okay, because this and this gives 0, and then you can work it out. So over here is actually a very nice question on integration by parts. Identify the u and the v prime, as well as learning how to integrate cosine square and sine square by deriving from the double angle formula and inputting it into your definite integrals.